This is video 5 from Unit 8, Lesson 5. So we're still talking about quadratics, but now we're going to start graphing them. So the next several videos will be over graphing quadratics in a different form. So first of all, the parent function of a quadratic equation is just this y equals x squared. This is the most basic form. So if we make a table and look at how this graph looks, pick some positives and negatives. Okay, so negative 2 squared, 4. Negative 1 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. So these are my ordered pairs. Okay. So this graph here is just 10 by 10. Alright, so negative 2, 4. Negative 1, 1. 0, 0. 1, 1. 2, 4. Okay, so I get this U-shaped. And that's what the apparent function of a quadratic equation looks like. So your quadratic equations will be a U-shape. They have this starting point here that we call the vertex. And in this case, our vertex is at 0, 0. They're also symmetric. So we have what's called the line of symmetry that goes through the vertex. And so all the points on the right can be matched with points on the left of this line. We'll use that to help us graph. Okay, so there's 3 main forms. We have our standard form. Vertex form is what we're going to look at in this video. And then we'll look at intercept form a little bit later, in a couple videos later. So vertex form, what we're going to look at now, tells us what our vertex is. So remember, the vertex is that starting point. So the vertex is H. Okay. Keep in mind that you have this negative in your formula. Oh, and I'm missing a squared here. Should be a squared. So this minus here in the formula is telling us we want the opposite of H. So if this were x minus 2, my vertex would be positive 2 for the x. I want to go back a little bit and talk also about a pattern. So when we're squaring x, our y values are x squared. So if we go over 1, we'll go up 1 squared, which is 1. If we go over 2, we'll go up 2 squared, which is 4. And we could also find another point by going over 3 and then up 9. 3 squared is 9. So there'd be another point up here if I continued. And of course I can match it on the other side as well because of that line of symmetry. So we're going to use that pattern to help us graph. Alright, so let's look at just some examples. So for vertex form, we might see just x minus 2 squared plus 3. Okay, so then my vertex, my starting point would be at positive 2, because we do the opposite, and then just what's added or subtracted, which is 3. Alright, so let's practice graphing some now. Okay, so I have y equals x squared plus 4. Let's go ahead and make a table, and then we'll talk about the pattern. So vertex form has this a in front, and as long as their a is just 1 or negative 1, then you can use the pattern. If it's not, then we'll just have to make a table. So again, let's just start with these points here, -2, -1, 0, 1, and 2. And if we can't really see the whole graph or we're not sure, we can always add more points. It doesn't matter. Alright, so you're plugging in -2 for x. So I'll just do that to the side here. Alright, -2 squared plus 4. Notice that I did put that in parentheses, because if you don't and you type in your calculator, you're going to get it wrong. Alright, so -2 squared is 4 plus 4, that's going to give me 8. This will give me 5, 4, 5, and 8 again. Okay, so these are my ordered pairs. Again, it's just a 10 by 10 graph. Alright, -2, 8. -1, 5. 0, 4. 1, 5. And 2, 8. Okay, so here's my graph. I didn't mention before, but this U shape actually has a special name. It's called a parabola. So here's my parabola. It opens up. And from the parent function, we've just shifted it up 4. So remember, the parent function, I'll sketch that in real quick, was this. Okay. So from the parent function, we shifted up 4. Well, where do you see up 4 in the equation? Right here, plus 4. Remember vertex form. Well, I don't have a number in front of x squared, so a is just 1. I also don't have parentheses, so really this is an x minus 0. And then my k would be 4. So my vertex is at 0, 4. So this plus k was how I shifted vertically. So my vertex went from 0, 0 to 0, 4. So up 4. So I could take my parent function and just shift it up 4. Okay. Alright, let's look at this one. So y equals x minus 3 squared. Alright, well here's my vertex form. X plus 0. I don't have anything added or subtracted. So my vertex, remember, opposite of what's inside parentheses, so positive 3, and then what's added or subtracted, which in this case is just 0. So from my parent function, so this time I'll use opposite and have the parent function in blue. Y equals x squared. So this is the parent function. Remember, we also could have 3, 9 as well. I'm just going to dash this. Okay, so from my parent function, my vertex moves from 0, 0 to 3, 0. And then everything else stays the same. So all the points are just shifted to the right 3. And remember that pattern I was talking about. So as long as you start from your vertex, you can use the pattern. Over 1, up 1. Over 2, up 4. Go back to your vertex every time. Over 3, up 9. And then match them on the other side of this axis of symmetry. And here's my graph. can always grab your parent function and then apply, they're called transformations or translations, moving them left, right, up, down. Or, as long as there's not an A value, you can just use the pattern, like identify your vertex and then use the squared pattern. If none of that makes sense, you can always make a table. Okay, so writing this out in vertex form. So this time my A is -1. So it's still, you can still use the pattern, but something changes when it's negative. So since I don't have parentheses, that's meaning I have just x minus 0 squared minus 2. So my vertex is 0, -2. Okay, so 0, -2. Alright. What this negative does is it reflects your parabola. So instead of opening up, it is going to open down. So I'm going to use the pattern, but I'm going to open down. So I'm going to go over 1, down 1, over 2, down 4. Start from your vertex every time. Over 3, down 9. So by using this axis of symmetry, I match on the other side. So if this point down here is 3 units away from this line of symmetry, then I can mark 1 3 units away on the left. This is 2 units away, so this one's 2 units away on the left. Okay, not a very pretty drawing, but you get what I mean. So this negative out front means the parabola will open down. Okay? So sometimes they might have a question that will say, how does this graph differ from the parent function? So remember that parent function again, y equals x squared. So it looks like this. Okay, so that's the parent function. So how does our graph, the one here in red, differ? Well, for one thing, it's reflected. It opens down. And then also that -2 in our equation tells us that it shifts down.